So this is a continuation of inverses video, but now we're going to verify that things are inverses, and we're going to graph inverses. So how do you verify? Well, to verify that f of x is an inverse of g of x and g of x is an inverse of f of x, what you have to do is you have to do a double composition of functions. What you need to do is you need to find f of g of x, and you have to find g of f of x. And they both have to simplify to x. If they both simplify to x, then yes, you just verified that they are inverses. So, to work with this, let's see, we'll give f of x dark blue, and we'll give g of x light blue. So, to find f of g of x, we would just take 2, and here's our x and f of x. And we finished with our plus 5. Now we're going to plug g of x into the x, so that's x minus 5 all over 2. And now we're just going to simplify from there. So 2 and divided by 2, they cancel, leaving you with x minus 5 plus 5, which, of course, you see those cancel, so you're just left with x. So you're good to go with that, but you must check both ways. So if we're going to plug f of x into g of x, we have our x right there with a minus 5 all over 2. And now we're going to substitute our 2x plus 5 in there for our f of x. And the same things are about to happen. The positive 5 and negative 5 are about to cancel. And you're left with 2x over 2, which we know cancels, and it leaves us with x. So we are good to go. So yes, these are inverses. And that's exactly what you do with the next one. So I'm going to let you pause the video and you verify that f of x and g of x are inverses for the second problem. Go give it a try. And hopefully you found that these are not inverses. If one of these would have been a plus 6, then they would have been. However, you've got to follow your math correctly. So once you substitute this x squared minus 6 into this x, what you would have wanted to happen is a positive 6 and a negative 6 to cancel each other out, and then the square root of x squared would just give you x, but that did not happen. So, since you could not get those to simplify to x, when the composition of inverses, or what you think are inverses, do not give you x, then they're just straight up not inverses. So this took you one step and you're done. You do not even need to check the other way because they both have to simplify to x to make it an inverse. All right? So now what we're going to do is we're going to graph functions and the inverse, and we're going to find out, is the inverse of the function also a function? So what we're going to do is we're first going to go back old school, and we're going to graph a line. So the first thing we do is graph 1/2 x minus 2. So that's going to be starting down 2. We go up 1 over 2, up 1 over 2, up 1 over 2, and you know exactly what we're going to do here. We're just going to keep on going back and forth. Now, we don't have to go back and forth forever for you to understand what's about to happen. So you have a line. And, of course, if you forgot how to graph that line, you could always use your graphing calculator. So that's what we have, 1/2 x minus 2. So how are we going to graph the inverse? Are we going to find the inverse and then graph it? Yeah, you can do that if you really want to. You can switch the x and y. And that would give you your x is equal to 1/2 y minus 2 and add 2. So that's going to give you an x plus 2 is equal to 1/2 y. Then you're going to multiply both sides by 2. And you're going to get y is equal to 2x plus 4. You could do it that way. So we go to 4. And we're going to go up 2 over 1, up 2 over 1, up 2 over 1. And we're going to go backwards in that exact same fashion. And as you can see, you're going to get a line again. But what's the other way you could have done that? You could have saved yourself some time, and if you remember what we talked about in yesterday's video, they're just reflections over the line y equals x. So all you had to do was graph the green one and then switch your x and y. So this 0, negative 2 became negative 2, 0. This 4, 0 became 0, 4. This 8, 2 became 2, 8. So it's just the reflection. So now the question is the inverse, in this case our purple line, a function? And the answer to that would be yes. And the reason why it's yes is because that passes the vertical line test, or the horizontal line test is passed in the original equation. So to determine if f of x is a function, you can do the vertical line test on the actual inverse, or you can do the horizontal line test on the original function f of x. You cannot do the horizontal line test on the inverse function. That would not work for you, okay? So that's it. All you have to do is graph the original and then switch your x and y's, or you can actually go through the algebraic process and find the inverse by hand. Okay? So in this next one, we just have to graph x squared plus 2. So that's going to give us a graph that looks a little bit like this. And we know it's going to be a parabola that starts up 2. So how do we take the inverse? Well, you can go through the process again, or you can use what might be a little bit of a faster method. And then you're just going to switch your x and y. And let's see, we are going to find out for this one that we're going to switch this 0, 2 to become 2, 0. This 1, 3 becomes 3, 1. This negative 1, 3 becomes 3, negative 1. And our 2, 6 becomes 6, 2. And our negative 2, 6 becomes 6, negative 2. And if we look at it this way, we see that, again, it's just a reflection over the line y equals x. So the question is the inverse a function? Well, think back. We can do the vertical line test on the inverse. So since this dark blue is our inverse, bam, 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 it fails. So no, it's not. Or you can go back to the original and do the horizontal line test. See, look, if you do horizontals on the original, it's still no. Okay, so in this case, no, it's not. And in the first one, the answer was yes, it was. That's it on inverses. This is Longo. I'm out. See you. Bye.